Hey everybody, it's Mr. Carr again. Today we're going to be looking at 4.3 day one. Today we're just doing some more triangle stuff, but we're going to look at some special proportionality things. First one is called the triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So we have parallel lines here. Then what we get is proportions that are that we can set up like basically across from each other, like here and here. So basically, I could do QT divided by SU is going to equal to TR divided by UR. Okay. Actually, I don't need to put those extra. Yeah. Let's do that again. Okay. So it's QT over SU, TR over UR. Now, this is not the only proportion we can set up. We can actually do a couple of other ones. So, for example, if I go this way, I could do QT over TR. QT over TR, and that's going to equal to SU over UR. You just need to be consistent with the way you set it up. The converse of our triangle proportionality theorem also applies. If a line divides two sides of a triangle proportionally, then it must be parallel to the non-intersected side. So if, in this case, RT divided by TQ, so I did this over this, equals RU over US, that means that these must be parallel. So QS is parallel to TU. Okay, so we can use that in a few different possibilities here. Our first example was the length of QU here. QU, I'll put a little X right there in that spot. Based on this diagram, and again, it doesn't fully matter how I want to do this because since I have parallel lines here, I can do 10 over 12, X over 6. So 10 over 12 equals X over 6. If you want to divide out 10 and 12 a little bit to smaller numbers, go for it. Divide by 10, divide by 2, I get 5, and then divide by 2, I get 6. Well, here, I actually have a shortcut for finding my X value. Since this is 6 and 6, then I can just take 5 and X, and they're equal to each other. I don't have to cross multiply here. Now, I just want to show this. This isn't the only way I could have set it up. I could have done something like this. 10 over X, 12 over 6. Okay. This one I'll just cross multiply just to show it. If I cross multiply, I get 12x is equal to 6 times 10, which is 60. Divide by 12, and I get x equals 5. Same thing. So it does not matter as long as you're doing consistent things. One other big idea here, don't forget, the parallel line inside the triangle makes two similar triangles. We have something like this and this. We have angle. Or I could have done the reflexive angle as well, but we have angle between the two triangles. So you can always treat them as two separate triangles as well if you wanted to. So for our next example here, we got PA is Y. So that's Y right here. AQ is 4, AB is 12, and then QR is 20. Find the value of Y. This is a great example of that. Notice how when I did my proportions, I did side length here to side length here, this side to this side, right? I did here to here or here to here. I never involved the parallel sides themselves. Here, I have to use the parallel sides. I don't have any information here and here. So this has got to be done a little bit differently. You have to treat it like it's two separate triangles in a way. So for example, if I take this triangle, and go ahead and just pull that out here. There's triangle 1. Put that Y back in place. Yeah. Triangle 2 is this one. Okay. So I pull that out here. So here's my second triangle, but that's going to be made up of 20 and Y plus 4. Okay. So I have to treat it this way if you're using the parallel side. So I'm going to put that as a special note. If using parallel sides, treat as two similar triangles. Okay, so now I've got it set up right here. I can do my Y over Y plus 4, 12 over 20. So I can cross multiply here. So I get 20y is equal to, if I distribute the 12 now, that would be 12y plus 48. Subtract the 12y over. So I'll bring it over here now. That's going to give me 8y is equal to 48. Divide by 8, and I get y is equal to 6. Okay. So again, if you're using the parallel sides, you have to separate them as two different triangles then. Okay. Next one, 3 parallel lines and 2 transversals. If 3 parallel lines intersect 2 transversals, so that's referring to this line and that side. Those are my 2 transversals there. They divide the transversals proportionally. So what that means is you've got UW over WY, so I could do this over this. Then I'm going to do the same thing from here to here. VX over XZ. But again, just like before, you can do a couple of them. You can go across each other. You could do it as UW divided by VX, and then that would be WY over XZ. So that's fine. So if you do that over that, that over that, that works as well. So in our next scenario here, a farmer's land is divided by a newly constructed interstate. Distance shown is in meters. Find the distance CA, which is right here to right here, between the north border and the south border of the farmer's land. There's 2 ways I could do this problem. One way is if I call this side X, let me zoom in a bit here. It's a little bit. There we go. If I call that missing piece X, I could solve for that. I have 3 parallel lines, 2 transversals. So I could set it up just like this. Here's these, and these are going to be proportion. Or I can go vertically. It doesn't matter. So I can do this as, I will do vertically. I like that. I like the look of that better. So instead of doing this way, let's do it as 2,000 over X, 2,500 over 3,000. So 2,000 over X equals 2,500 over 3,000. So I cross multiply here. So I got 2,500X is equal to 6,000,000. Divide both sides by 2,500. So I get 6 million divided by 2,500 gives me X is equal to 2,400. But I want to find the length of CA here. It's the entire length, which is made up of 200 or 2,000 and X. So CA is going to equal to 2,000 plus 2,400. So CA is equal to 4,400, I believe, meters. Okay. Now, another way I could have done this, maybe save a little bit of steps here. Let's call this length Y. CA is what I'm looking for. We'll call that Y. This length here is the whole thing is 2,500 plus 3,000, which is 5,500. Okay. All right, sorry. Okay, so 5,500 right there. So these are also in that same proportion. So if I can do, like, for example, Y over 5,500, doing this over this, I can do 2,000 over 2,500. Okay, so from here, I'm going to cancel out these common zeros, make it smaller. So 25 times Y is equal to 20 times 5,500. Which is 110000. So 110,000. Divide both sides by 25. And I get Y is equal to 4,400 meters. I'm just showing both ways because I just want you to be aware that we can set things up in multiple ways. You just need to be consistent. So I figured out call the entire length CAY, that over the entire length going from here to here. That's the same proportion as any of the pieces going in the same direction. Okay, so I did like left over right. Or I do top over bottom. But then if I do that, I got to figure out what X is here. I got to add that back onto the 2,000. Okay. But that's it for today. So 2 main theorems. We have our triangle proportionality theorem and our 3 parallel lines and 2 transversals. So we basically are just creating proportions in multiple ways. That means we could solve them in multiple ways, mostly using our cross multiplication, but just making sure you're being consistent. All right. That's it for today. Take care.